Hey, what's up? Welcome back to my channel where we create apps using Flutter from scratch. In this one, I'm going to show you how to code the entire chess game using purely Flutter, and it's actually really fun, so let me show you by jumping into the code. So I've opened up a brand new Flutter project and you should just get this Flutter demo homepage. Now I'm going to delete everything below the main function so that we can create this from scratch. So in the material app, I'm just going to make this debug banner false, which is that little thing in the corner. And let's go to our game board. So let's create a new file called gameboard.dart. And I'm going to create a stateful widget here with just a blank scaffold. So if you come back to the main file, let's import this. And if you save it, we should just have a white blank app. So this is where we'll begin. Now in chess, the first thing we're going to need to do is to create a grid. So let's use a gridview.builder, which by the way, I've made a separate tutorial on, so check that out if you need. But I can show you real quick here how to do it. So the cross axis count in chess, it's an 8x8 board. So in one axis, I want 8. And for the item builder, for now, I'm just going to print out the index just to show you how this works. So if you save this, you can see it starts from 0, 1, 2, 3, 4, and then it goes on forever. So this is why we should specify an item count. So like I said, chess is an 8x8 grid. And one thing is I actually don't want this to be scrollable. So you can change that in the physics, never scrollable physics. And so these numbers, I like to show this at the beginning because this index, you can see clearly what the numbers are doing. Cool, so now instead of just displaying the number, I want to display a sort of square tile. So I'm going to create a new folder called components. And in this components, let's create a file called square. Now, the only thing I want to know about this square is a boolean to see if it's a white square or not. Okay, so we want to try to create that kind of checkered board. So in the container, if you look at the color, let's say, is it white? If it is, then let's just give it a sort of light gray. And if it's not, let's give it a bit of a darker gray. So just save this, and if you come back to the grid, let's return the square, and you can see it says auto import, so press tab. And we have to fill it out saying, is this a white square or not? So like if I say true, then it'll just be the lighter gray, and then if I say false, it'll be the darker gray. So how do we make this checkered? Well, I showed you guys the index, right? Now, a very naive way to approach this would be maybe all the odd numbers and even numbers we can alternate to show a checkered pattern. So this is the kind of original thought, but I just want to show you guys here. Let's say if the index and the remainder when you divide it by 2 is 0, so in other words, this is an even number, let's return false for it being white, and then show the other color for all the odd numbers. So if you actually do this and you save it, it'll create a pattern like this, which is actually not what we want. So it's not just a even number, odd number difference. We're going to need to do a tiny bit of extra math. So instead of this, what we're going to do is let's just create an integer x and also integer y. So the first one gives us the integer division, which tells us about the row. And the second one tells us about the remainder division. Okay, so this will help us alternate for each square. So let's say like boolean is white, and we're going to say x plus y. And if this remainder is even, then let's return the square. So if you save this, then we can get this nice checkered pattern. Cool, and by the way, this little bit of code is going to be pretty helpful for us later on. So I want to grab this and put it in a new file called helper. So I just want to put some common helping methods here. And this one is going to be called isWhite. And so let's put all of this code into this method. And so now if I come back to my grid, it makes it look a little cleaner. So that's much better for us to read. Sweet, now let's focus on trying to display the pieces on the board. So if you come over here, I've actually prepared the images already. So I've got here the 5 main pieces. So you can see the rook, pawn, king, queen, etc. Now you can get these images anywhere on the internet, but if you want to use my specific images, then you can download my code from below, which will include the entire code as well as the assets. But like I said, you can just get any image you want from the internet and put it in this folder, and then go to your project folder here, and we're just going to drag it into the library. So if you come back to our code, we have to tell it in the pubspec.yaml that we're going to import some assets, and just specify where you placed the asset. Cool, so there's our images. Now let's try to place them on our tiles. So I'm going to create a new file here called piece.dart. And the first thing is I just want to have an enum. Now, if you don't know what an enum is, it just means we can specify different types of things. So for example, I want to have a chess type, and the different types that we can have is the pawn, rook, knight, bishop, queen, and the king. So now we can use this to create a chess piece class, right? So if we think about a particular chess piece, we need to know the type. We need to know the color, so is it white? And lastly, we're going to include the image path, which is what we imported just then. So let's create the constructors for these. Great, so now we can come back to our square.dart file, and we can actually give it a piece. Okay, so it could be null, meaning it's a blank square, or we could have a chess piece in here. And so what we'll do is, if there is a piece, then let's display it into the square. Right, so if the piece is not null, then let's return that piece's image, and otherwise just return nothing. So if you come back to our grid, you can see there's a little red squiggle because we have to specify the piece here. So just to show you real quick, let's say I want to create a piece here called my pawn. Right, so let's give it the type. Let's say it's white, and also just give it the image path. Sweet, so we created our first chess piece, and so if we give it to our square, you can see it's going to have a pawn piece in all of the squares. Great, so now let's actually give it a color. So if you look at the piece, if it's white, then we'll give it white, otherwise we'll give it black. So you can see if you control this is white boolean, that's how we can control the color now. Cool. Now one thing about this is if you look at the background, we made it slightly gray. So I want to have a better contrast here so that we can actually see the white and black pieces more properly. So what I mean is, for the checkered grid, let's make the lighter color 400 and the darker color maybe a gray with a strength of 600. And so, yep, I think that does a better job of showing the pieces properly. And by the way, at this point, it might be a good idea to store these colors in a separate file. So maybe let's have a new folder called values, and in a new file called colors, let's have a color for the background and also the foreground color. So if you come back to the square, instead of fixing it here, let's just give it the foreground and the background. Which means if you come back to the scaffold, let's also make the background color the same. And that way, if we need to make future changes, we can just go to the colors.dart file. Awesome, so now that we have a piece, let's actually create the game board for the chess. So in terms of the data structure, I'm going to go for like a 2-dimensional list representing the chessboard, with each position possibly containing a chess piece. So I'm going to have a list inside of another list. And let's just call it board. So at the beginning of our app, let's try to initialize the board. So this is going to have to be in our initial state. And to initialize the board, what I mean is let's place all of the positions of the pieces in the correct place. So the 2-dimensional list is going to be, the first list is going to have 8, and then 8 on the column as well. And at the beginning, we're going to initialize everything to be null, meaning there are no pieces in that position. Great, now let's start with the pawns first, and then we're going to place the rooks, and then the knights, the bishops, and as well as the king and the queen. Great, so let's start with the pawns. So for the pawn, we're going to use a quick for loop because we need 8 of these guys. And we're going to put them in the first row and iterate through the eye. And this is going to be a black piece. And on the bottom, we're going to have on the 6th row, a white piece. Cool, and just to see the progress as we go along, at the bottom of this initialize method, we're going to say board is equal to this new board. So if I save this, let's just make sure everything is working fine. So let's just delete this. And when you come back to our grid, let's place them in the correct position. So at the beginning, we're going to need to get the row and the column of the square. And so now for the piece, we can give it the piece on that particular position on our board, right? So if I just save this and I restart it, yay, you can see the pawns are in the correct position. So if you have any questions about any of what we just did so far, just put a comment down below and I'll try to help you out. But let's move on to the rooks. So there's going to be the castle. That's going to be at the top left position first, so 0, 0. And if I just save this, just to make sure, yep, there it is. And let's just copy this again. We're going to need 4 in total. Let's put them in each corner of this grid. And change up the colors. Sweet. Okay, we've got the castles done. Now let's go to the knight. And let's just save this. There it is. And we're just going to create a few more. Cool. So knights are done. Let's go to bishop. Great, and now we have the queens. And then the white queen. And then finally the kings. Sweet, and we have initialized the board. Great, now let's come back to our square.dart file, and now let's try to select a piece. So we're going to need to have a new boolean here called isSelected. So depending on if this square is selected or not, let's display a different color. So if it's selected, let's say the square is green. And otherwise, it's just going to be the white or black checkered background. Cool, and then now we can just give it the square color. Great, so if you come back to the game board, so we're going to need to have a variable for the selected piece. We can only select one piece at a time. And let's also keep track of the row and column of this selected piece so that we know the position of it. And we're just going to set it as -1 as a default value, meaning nothing has been selected right now. Sweet, so let's have a method here called userSelectedAPiece. And so when we call this method, we want to know where it's being selected. So we want to know the row and the column. So I'm just going to write a little comment here. So selected a piece if there is a piece in that position. So in other words, we're going to do an if statement and we're just going to check in this position on the board. If it's not null, meaning there is a piece in that position, then let's select it. And in this square, let's just say false for right now. And let's update the selected row and the selected column. So in the grid, when we return these squares, we're going to check if this current square is selected or not. So we're going to say boolean is selected, and this boolean is going to depend on if the selected row is this current row and also the selected column is this current column. And then we can just give this boolean to our square. So let's give this a go. Now, I want to select a piece, but I just realized we don't even have a gesture detector. So we want to make these pieces tabbable, right? So if you come back to our square, we're going to wrap our container in a widget called a gesture detector, which does exactly what it sounds like. It detects a gesture. So I'm going to go for an on tap. And if you hover over this, by the way, you can see it requires this sort of function. So I'm just going to require that at the top. And so what that means is if you come back to the game board, you can see another red squiggle because we have to give it the on tap. And we actually just created this method already, which is our piece selected. Great, so let's just save this and restart it. And if I select a piece, you can see that selected piece will now become green. Awesome, so far so good. Now what we need to do is if we select a certain piece, we need to know the valid moves for the currently selected piece. So the way we'll do this is let's represent each move as a list with two elements, so the row and the column. Cool, so if you go to our piece selected method, so after a piece is selected, calculate its valid moves. Now I'm going to call this method calculate raw valid moves. And you'll see why I'm calling it raw later, because later we want to calculate the real valid moves, because sometimes certain moves are illegal. And we'll get to that later on in the video. So just to keep it simple, we're going to calculate the valid moves. Now we're going to need to know the position of this, right? So the row and the column, and also which chess piece are we looking at. Cool, so let's create a list called candidate moves. And we have to account for the different directions based on their color. So for the direction, let's say if it's white, then the direction, let's say it's -1, and if it's black, let's do +1. So that's just for if we're going up or down. And then finally, we can use a switch statement. So if we look at the current piece's type, let's say the first case is a pawn, then we have a few other cases, right? So depending on the pieces. So we got a pawn, we have a rook, we got a knight, bishop, queen, and king. So let's just start off with the easy one, just the pawn. Now pawns can move forward if the square is not occupied. And as you know, pawns can move 2 squares forward if they're at the initial position. And finally, pawns can capture diagonally, right? Or they can kill pieces diagonally. So these are the things we have to account for. By the way, let's create one more helper method because we're going to use this a lot. So I'm going to create a boolean called isInBoard. So if we look at a certain row and column, we just want to make sure that it's within the board, right? So meaning the row has to be at least greater than 0 but less than 8. And same thing for the column. So we're just going to check if this future move that we're trying to go to is in the board. Right now, if you look at a pawn, it will be the same row and column, but for the row, we're going to add 1 direction. Okay, so we're just going to move up 1. So we have to make sure that this move that we're trying to make is in the board, and it's also null, meaning it's an empty square. Right, so if these conditions are met, let's add it to our candidate moves. Now, if we move on to the second condition, now the second condition is moving the pawn 2 squares forward, right? So we can only do that if it's at their initial position. So let's say for the black piece, if the row is 1, right? Meaning it's in the original position and it's also black. So if this condition is true, or, which is what this double line is indicated by, if it's a white piece and it's in row 6, then these pawns are in their initial positions. So if that's the case, then we can do a similar check. So we're going to say row +2, and we're also going to just check if it's in the board and also if these positions are null. Then we can add it to our candidate moves. Great, and then finally we have the situation where the pawns can kill diagonally. So for this one, we're going to add 1 direction to the row, but also we're going to subtract 1 for the columns. Okay, and we have to make sure, in this case, you can see I'm saying now, if this position is not null, meaning there is a position in there, and it's also white, then this is a valid move. Okay, and we're going to copy this and just change all of these to +1 for moving towards the right diagonally. Okay, so just before we move on to the other pieces, let's just make sure that the pawn is moving correctly. So we have to return at the end the candidate moves, right? So if I save this and run it, looks like nothing is happening, and that's because we need to reflect it in this square. So if you come back to our square, we have to accept another boolean to check if this particular square is a valid move. Okay, so if you look at our square color now, you can see if it's selected, the square is going to be green. Else if it's a valid move, then we're going to make it, let's say it's green, but maybe like a lighter green. So we can see a difference. So come back to our game board, you should see our red squiggle because we have to specify if this is a valid move or not. So right before we return the square, let's just check if this square is a valid move. So initially, let's just say false. And what we're going to do is we're going to do a for loop and check each position in the valid moves. And we're just going to compare the row and the columns. Okay, so if any of the positions are in the same square, then let's say valid move is true. And then finally, we can return this to our square. Great, let's save this and check it out. So if I restart this and I click on these pawns, then you can see there's a green square for the valid moves. Nice. Now, one thing is you can see in the white one, it's only showing one valid move, but it looks like the black one is showing the 2 valid moves, which is correct. So let's just check our code again. In the pawns moving 2 squares forward, let's see if I made any mistakes here. Oh, I see where I made a mistake. I forgot to account for the direction here. Yep, there we go. So if I check this out, sweet. Now both black and white is working. Great, now it's time for the rook. So again, let's just put some comments here so we know what we're doing. For the rook, we're going to move horizontal and vertical for the directions. I'm going to say -1, 0 for going up, 1, 0 for going down, and 0, -1 for moving left, and 0, +1 for moving right. So let's do a quick for loop and just check each direction in the directions. And inside here, we're going to use a while loop so that we can just get every square until we hit a roadblock in a particular direction. Okay, and we're going to break out of this while loop when the position I'm trying to go to is not in the board. Let's also check for if the position I'm trying to go to is not null, meaning there is another piece in this position. Then let's check the color, because if it's white and our piece isn't white, then that means we can kill it, meaning it's a valid move. Right? But if we run into another piece that is our own color, then that's not a valid move because we can't kill our own piece, right? Great, so then we can break out of this loop and just add it to our candidate moves for all the other squares up until this point. If you have any trouble understanding any of this code, like I said, leave a comment below and maybe put a timestamp so that I can kind of easily help you out. Awesome, now let's move on to the knight. Now for the knight, we have 8 possible L shapes that the knight can move into. So for the knight moves, I'm just going to list out all the possible moves that we can have. And then let's do something similar. So we're going to do a for loop to go through all of these moves and give it to our new column and our new row. And we're just going to make sure if it's not in the board, then we're going to continue. But if the position I'm trying to go to is not null, meaning there is another piece in there, then again, let's just check the color of it, because if it's different to our color, then that means we can kill it. So that's a valid move, which means we should add it to our list. Right? Otherwise, if it's the same color as us, then that's not a valid move. We can't replace our own piece. Cool, so let's just save this and test out the knight. And looks like it's not right. And I know why. We just made a little typo here. So let's just fix this to a plus. And let's check this out. Sweet, you can see that the knight has those moves there. Awesome, so we're almost there. So let's go to the bishop now. So this is going to be similar to the rook, except for the fact that this is moving diagonally, right? So let's get out the directions again. And then let's go through each direction in this direction list. And we're going to use another while loop because we want to keep going until we can no longer move. Right, so we can keep going diagonally until the position we're trying to go is not in our board, right? Then we can break out of this loop. If that's not the case, we can check if there's another piece in that position we're trying to go to. Now, if that same piece is a different color to our piece, then that means that's a kill move. So we can add that as a valid move. Otherwise, if it's the same color, then we can break out of the loop. And so everything up until this point, let's just add the moves. Sweet, now moving on to the queen. Queen has all 8 directions, up, down, left, right, and the 4 diagonals. So let me just type this out. And again, let's do another similar for loop. And we're just going to make sure that it's in the board. And let's check it if it runs into another piece. Then just check the color, because if it's a different colored piece, then we can kill it, meaning it's a valid move. Otherwise, we can break out of the loop if it's the same color as our piece. Cool, and then finally we got the king. So I'm just going to grab all these directions from the queen because it's going to be the same. Now the difference between the queen and the king is the fact that we don't need this I to iterate through because we can only move one spot, right? So we're going to get rid of the I. And that's pretty much it. So let's test this out because maybe there might be some issues. So what I'm going to do is when you initialize the board, just to test this out, let's just place a piece in the middle of the board. Okay, so let's just say like in the position 3-3. Let's start off with the rook because we didn't test that one. So if I save this and I restart it, you can see there's our rook in the middle. And if you click it, then let's just make sure it's behaving correctly. So yeah, it's moving all the way horizontally as well as vertically. Now, one detail about the vertical right now, you can see if it's a white piece, like it's the enemy piece, then that is a valid move. As opposed to when it runs into its own colored piece, then that's not a valid move, right? So that's what some of the logic in the code that we figured out earlier. Now let's get this knight and see if the knight is moving fine. And great, you can see there's the 6 moves because the 7 and 8 moves is going to be its own piece, so that's not a valid move. So it looks like it's working fine. Let's check the bishop. Ooh, looks like the bishop, something is not quite right with the bishop. Let's check this. Oh, I should not start at 0. I should start at I equals to 1. Yeah, let's save this and restart it. Yep, there we go. That fixed it. Cool, and then let's check the queen. Yep, queen's working fine. Let's just minimize these, and now it's time for the ability to move the piece. So let's create that method now. For the parameters, we're going to need to know where the new position is. So let's grab the new row and the new column. So we're going to move the piece and then clear the old spot. And we're going to clear the selection. So if we have a look at the board for this new position, we're going to assign that new position to be our currently selected piece. And then the current position, we're going to make it null. And then we're going to clear the selection. So let's just quickly set the state and just make the selected piece null and the selected row and column -1 and the valid moves as well. Just reset everything. So we made the method. When should we call it? So we should call it when we, first of all, select a piece. And so in this, if there is a piece that is selected and the user taps on another square that is a valid move, then we can move there. So you can see this first if statement, it checks for the square currently being selected if there's a piece. So that's the first if statement. Else, if the selected piece is not null, meaning we have something in the selected piece, and we just need to make sure that the position we're trying to go to is a valid move. So if you look inside the valid moves, let's just check all of the moves inside this list and just compare the row and column. Okay, so if it is a valid move, then we can finally move to that location. Now I saved it and it looks like we have some sort of error, right? It says a null check operator used on a null value. Okay, let's just put a little bit of code here. So if the piece happens to be null, we're just going to return a blank valid moves. So if I save this and I restart it, then yay, you can see that we can now move to a valid position. Great, so far so good. Now, I just want to make one minor visual change, which is for the valid moves, instead of changing the entire square color, I'm just going to add a little margin just so that we can see these squares properly. Yeah, so something like this. Just a little minor visual adjustment. Awesome, so now that we can move to different positions, one thing that if you play around with this, you'll notice that we can't actually kill a move, right? If I'm a queen right here, I should be able to kill these pawns, but if I select on the pawn, it looks like that piece is getting selected. So we're going to need to adjust our code a bit. So the first part of this, when we select a piece, I'm just going to get rid of this for now and say no piece has been selected yet, and this is the first selection. The other condition is there is a piece that is already selected, but the user can select another one of their pieces. So if the selected piece is equal to null and the square that we just tapped has a piece in there, then we can just do what we did before. So grab the selected piece, the selected row and the selected column. Now this is the important adjustment here. So else if there is something in this position, and if the color of this particular position is the same color as the selected piece, then this means that the user is just selecting another one of their own pieces. So it will be the same kind of code there. Now, the reason why this adjustment is necessary is if we just save this and test this out. So going back to our queen, so if you click on one of these pawns, then we should be able to just kill it now. Now, since we can kill some pieces, let's actually display the pieces that have been killed, just so that we know in the game how many pieces have been taken. So I'm going to need a list of white pieces as well as black pieces that's been taken. Cool, so now that we have these lists, let's find the place when we do the kill. So when you move the piece, right, and we clear the old spot, let's just do a quick check here. If the new spot has an enemy piece, then we're going to add the captured piece to the appropriate list. So if that new position that we're trying to go to is an enemy piece, there's something in there, then let's just grab that captured piece and put it in the appropriate color. So if it's white, then we're going to put it in the white list, and otherwise we'll put it in the black list. Awesome, so now we can come back to our UI. So we've got a big grid. What I'm going to do is put it in a column, right? So we've got the chessboard in the middle, and at the top, I want the white pieces taken. and at the bottom I want the black pieces taken. Now, if you've ever worked with grid views before, which I've done many times on this channel, you would know that we need to specify a height, right? Especially when we're in a column like this. So one easy way to do this is to just expand this grid view just to fill up the rest of the space. And I'm going to use an expanded widget for the other two sections as well. Okay, and we're going to display a grid with a cross-axis count of 8. And now we have to display the dead pieces. And this, I think we should create it in another file just to keep our code nice and clean. But just before we do that, the item count, it should just be the length of our white pieces taken. Now let's come to our components and we're going to create this dead piece file. And the only thing I need to know with this is really just the image path and the color. Right, so for now, let's just return the image and let's just make this work first. So if you come back to the game board, we have a red squiggle. We can now import this dead piece we just created, and we have to specify these two things, right? So let's go through all of the white pieces that are taken and just get the image path as well as the white pieces. Let's copy all of this and do the same thing for the black pieces. And this one should be false. Cool. Now if you save this, you can see like if we have 3 expanded widgets, it's going to divide the screen into thirds. But for the chessboard, I actually want this to be bigger than the other 2 sections. So you can see under the expanded widget, you got a flex property here. So I want this to be 3 times as large as the other widgets. Cool. And let's kill something. Good. So if I kill a pawn, you can see that now everything's getting killed. Awesome, except for the fact that the color is not being represented properly. And so now we can come back to our dead piece and we can say for the color, if it's white, then give a white color. Maybe we'll just go for like a gray. And for the black, let's go for a darker gray so that we know it's kind of like a dead piece, kind of gray it out a bit. Looking good so far. Now, if you actually scroll this, I don't want this to be scrollable at all. So let's put our never scrollable physics. And everything should be working fine. So I'm just gonna, just for testing purposes, let's just kill all of these pieces and see how it lines up. Yep, there you go. Looking good. Sweet, now that we can move all of our pieces, let's take into account for turns. Okay, so we're gonna create a boolean to indicate whose turn it is, whether that's white turn or black turn. So I'm just going to call this is white turn and we'll say true since white always goes first. Now, if you go to your piece selected method, we want to make sure you can see that we can select both white and black right now. So in this first little condition, in the if statement, I'm just going to do another if statement and just check for the turn. Okay, so if the current piece is the white turn, then we can move. So if you save this and you restart it, then you can see I can't select any other black colors right now. We can only select the white. Cool, which naturally means after the move, we should switch turns, right? So after we go to the move, then let's change turns at the end. Cool, so let's test this out. Now, if I move a white piece, I can't move any more white pieces because it's black's turn. Great, and we can also kill pieces as you can see. Cool, so now what we need to do is, the next condition is we have to check for the checkmate, or I guess the check, right, for the king. So one useful thing to do is to actually keep track of the position of the kings. Okay, so keeping track of this will make it easier to do the king check later on. So for the white king position, that's just going to be 7-4, and black king position is going to be 0-4, right? So these initial positions should be the same thing as when we initialize the board. If you go all the way down to the king, it should be 0-4 and 7-4. Sweet, and let's also naturally just have another boolean just for the check status, which currently it should be false. Awesome, so when we move a particular piece, let's also see if any kings are under attack. So if king is in check, then we can change up the check status to true, and otherwise we can say it's just false. Right, so let's create this is king in check method right now. And this one's just going to be a boolean, so it's just going to return true or false. And let's also accept for the parameter if we're looking at the white king or not. So let's start by getting the position of the king. And so this one is just going to depend on, is it the white king or is it the black king? And then once we have that, let's check if any enemy piece can attack the king. So to do this, so let's do a quick for loop to go through all of the squares. Now we can obviously just sort of skip through the empty squares and also the pieces of the same color as the king, because we only want to check the enemy pieces. So if it's null, or it's the same color as the king, then let's just continue. Otherwise, let's get the valid moves for this particular piece, and we're going to call that method we created earlier, so calculate raw valid moves. And once we have all of the valid moves from the opponent, let's check if the king's position is in any of these pieces' valid moves. Right, so let's just compare the row and column position for the king. And if we're in there, then let's return true. And at the end, if we don't meet any of these conditions, then we're going to return false. Awesome. So if I come back to this, we can have a red squiggle there because we have to give it the parameter. So whose turn is it? And finally, let's come back to our UI and let's just display the game status as a little text widget here, just so we know if it's in check or not. So if the check status is true, then let's return check, and otherwise return nothing. Okay, let's try this. I want to put something in check. And you can see my queen is now able to kill this king, so you can see now it says check. So from this king, if I kill this queen now, you can see the check status goes away. Sweet, so it looks like that's working fine. And oh, it looks like we have a little bug here for the pawn. So it looks like we actually can't kill diagonally. So what's going on here? We should add this extra condition. Forgot to finish this off. So if the piece is not equal to the color, so if it's an opponent color, then we should be able to kill it. So let's do that for both of these conditions. And let's try again. And there we go. So fixed that part. Now, one thing I want to show you next is the next problem is if you look at this queen, right? This particular queen should affect the valid moves for the white king, right? Like you can see, if I select on this white king, it's showing me that the available valid moves, but we know from the rule of chess that each of these moves are actually not valid because your king will be under attack. So we have to make sure that certain moves we can't do if that move is going to put our king under the check. In this move piece method, check if the piece being moved is a king. So if we are moving the king, then let's update the appropriate king position. And so again, just to show you what the problem that we're trying to solve right now is, if we have the king like this, some of these moves that are valid shouldn't be valid because it'll put the king under attack, as you can see. So that's why, if you remember, when we calculate valid moves, I called it calculate raw valid moves, right? Because some of these valid moves shouldn't be valid. So let's have another method here called calculate real valid moves. So what we're going to do with this one, the parameters we're going to accept is going to be the same row, column, and the piece, but I'm going to have another boolean here just to check the simulation. And what I mean by check simulation is we're going to simulate the future move to see if that move is a valid move or not. So I'll show you here what I mean. Let's create a list here called real valid moves. And let's have another one called candidate moves, which is going to be those raw valid moves that we had before. So this will calculate every possible move that we can have. So after generating all candidate moves, let's filter out any that would result in a king check. So if we are checking for the future simulated move, let's go through each move in these candidate moves and grab the end row and end column, meaning the position I want to end up at, right? So the future position I'm trying to go to. And then here we have to do a quick check and say, just make sure that this simulated move is safe. So if it's safe, then we can add it to our real valid moves. Else, real valid moves is going to be equal to candidate moves. Right, so this little bit of magic is going to simulate the future move to see if it's safe. So let's create that method right now. So simulate a future move to see if it's safe. In other words, it doesn't put our own king under attack. And the parameters we need for this one is the chess piece. We need to know the start position and also the ending positions. So when we're simulating a future move like this, it's always important that we save the current board state because we want to return back to it if it's not safe. And then if the piece is the king, save its current position and let's update it to the new one. And then we're going to simulate this move and check if our own king is under attack after that move. Okay, so once we know whether it's safe or not, if it's not safe, then we're going to restore back to the original state. So let's grab the chess piece that was the original one. And let's also get the original king position as well, so that we can return back to it later. And so now that we've saved the original king position, we can now see what this future position is going to be. So the white king and the black king, let's give it this ending position, that where I want to end up. And let's try to simulate this. So let's put it on our board. And we're going to clear the original position. So now we can check if this king is in check. Right, so now that we have that boolean, we can now return everything back to its original state. And just return that boolean if king is in check or not. So by the way, if this king is in check, then we're going to return the opposite of it, right? Because this method, we called it simulated move is safe. So if the king is in check, then that's not safe. So that's why we're just returning the opposite here. Sweet, so if you come back to our code from moving the piece, the simulated move is safe. It has a red squiggle because it requires some parameters. So we're going to give it the piece, the current row column, and the ending row and column where you want to end up. And everything's set up now. So if you come back to our method here, so if a piece is selected, calculate its valid move. So right now we're just calculating the raw valid moves. So now we can replace this with calculate real valid moves. Okay, and we're going to say true at the end to simulate the future moves. Awesome. And same thing with the is king in check method. You just want to change these to calculate real valid move. Okay, so let's save this and restart it and let's see if this works. So I'm just going to play this game and come back to that position we had. So right now the king is in check. And if you click on the king, you can see it doesn't just show you all of the raw valid moves. It shows you the only moves that you can actually make, right? Like we have to kill this queen. There's no other option, right? We can't go to that bottom square. And if you click on any of the other black pieces, you can see it doesn't actually even show the valid moves because it's not a valid move. Right now, you have to move that king. Okay, so looks like it's working fine. Let's try it for the other side. So I'm going to bring the queen over here. And right now, the king is in check. And if I click on this king, again, this works perfectly. So the king's raw valid moves, right? We should be able to move like diagonally. But if you move diagonally, then you're still going to be in check. So that's not a valid move. So you only are able to move, in this case, bottom and top left. So hopefully that made sense. Let me know if you need any help on that. But we are pretty much done with this game. Now the last thing to do is to checkmate. Right, so if the king is not in check, then it's not checkmate, of course. If there is at least one legal move for any of the player's pieces, then it's not checkmate. And at the end, if we haven't returned at all, then there are no legal moves left to make. So checkmate. right? So the first thing is we're just going to make sure if it's check or not. Okay, if it's not even in check, then we can just return false, definitely not checkmate. And the next condition is we have to see if there is any legal moves that the other player can make. So if I just go through the 2 nested for loops to go through the board, again, we can skip through some of the empty squares and as well as the opposite color, right? Let's just check the current player's color. And let's get the valid moves and calculate these real valid moves. And so in this list, if this piece has any valid moves, then it's not checkmate, right? So if piece valid moves is not empty, then return false, it's not checkmate. And then at the very end, if none of these above conditions are met, then there are no legal moves left to make, so we can return true. It is checkmate. Awesome. So when should we check for this method? You can see here we change turns. So let's do it right before we change the turn. Okay, so we're going to check if it's checkmate after a move. And so if it is checkmate, by the way, let's return a little dialog box just saying, checkmate as a message. And maybe also give a action button to play the game again. Which means we have to reset the game, which is pretty easy. We can just say, let's first of all pop the dialog box. We want to initialize the board again, right? Set it back to the original and just change everything back to its original value. So check status is of course false. Let's clear out all the dead pieces and just set stated. And we should also put the king positions back where they belong. Okay, let's check this out. Okay, I want to go for a checkmate now, by the way. I'm going to intentionally checkmate the black guy. And this should result in a checkmate because there are no more moves to make. So why is it not checkmate right now? Oh, I know why. Because we should put an exclamation mark here. So if we made a move, then we're going to check for if the opposite, like if the opponent's king is in check. Right, so let's try this again. Let's do that quick 3-4 move checkmate. And there it is, checkmate. And then we can play again and everything's set back to 0. Awesome. And actually, I just realized one more thing we have to set back in the reset game is just make sure it's the white turn always at the beginning. Sweet, and that's the chess game that we coded entirely just using Flutter. Now, if you made it this far into the tutorial, leave me a purple heart in the comments just so I know. And good job, by the way. If you have any questions about any of this code and you don't understand it, just put a comment below. Try to be specific with your questions so I can help you out instead of just saying it doesn't work. Now, I hope you learned something. Thanks for watching and I'll catch you guys in the next one. Peace!